Today's video comes from section 4.2, where we're solving systems of linear equations using substitution. So in 4.1, we looked at graphical solutions, and this looked like a point xy where our line crossed. Here we're still looking for a point of intersection, but we're going to do this algebraically using a method that's called substitution. So you can see our 5 steps here. We're going to follow these steps as we work through the examples. So I'll put the first example up and then we'll go step by step. So number 1, we have 2 equations, x plus y equals 12 and y equals 3x. So step 1 says, in one equation, get one variable alone. So step 1, okay, that's already done for us. Equation 2 is y equals 3x. So check that step off. Now, step 2 says, in the other equation, replace the variable with what it is equal to. So we just solved for y. We're going to take that value for y, and we're going to plug it in to our other equation. So I'm going to get x plus 3x equals 12. So the only thing I changed was that I changed y into 3x. Step 3 says solve the equation for the given variable. So step 3, we have an equation x plus 3x equals 12. I'm going to combine like terms. I get 4x equals 12. Divide by 4 on both sides. It's going to give me x equals 3. So that's the first part of my solution. Okay. Now what I'm going to do for step 4 is take that solution, the value that we got in step 3, and plug it back into the original equation. So I'm going to take x equals 3, plug it back in there for x. So I get y equals 3 times 3, which is equal to 9. So now you can see I've got an x value and I've got a y value. So finally my solution, as always, is an ordered pair. So my solution as an ordered pair xy is 3, 9. So that would be my final answer. And if I wanted to check that that works, I could plug in for x and y in both equations, and I should get true statements. So we have a bunch of examples we're just going to go through and see what some of the different outcomes are. For our next problem, step 1. It's already done for us, solving for one variable. We've got the first equation, x equals negative 4y minus 1. So we're going to plug that in for step 2. We're going to plug negative 4y minus 1 in for x. Now here we have a 2 multiplying our x. So we have to have a 2 multiplying the whole quantity, negative 4y minus 1. Then we're going to subtract 5y and set it equal to 11. So again, I plugged in the first equation, the right-hand side, into the second equation for x. Step 3 says solve the equation you just created in step 2. So I have to start by distributing my 2. I'm going to get negative 8y minus 2 minus 5y equals 11. Combining like terms, I get negative 13y minus 2 equals 11. I'm going to add 2 on both sides. And I get negative 13y equals 13, which gives me y equal to negative 1. So I got my first value. I've got my y equals value. Step 4 says take that value, and we're going to plug it in for y in our first equation. So I have x equals negative 4 times negative 1, which is y. And then I'm subtracting off 1. That gives me 4 minus 1, which is 3. Okay, finally I want to write my solution as an ordered pair. So my solution xy is 3 is my x value, negative 1 is my y value. So 3, negative 1. So you can see, as long as you're following the steps, it's a pretty easy process. But there's some places where you can make mistakes with negatives and distributing, so just make sure you're working really carefully. In our next example, we've got Two equations again, a system of equations, both linear equations involving x and y. Our first step is solving one of the equations for one of the variables. Now in this case, equation 2 is easier to solve. We're going to solve it for x. Okay, by adding 2y to both sides. So x is equal to 2y minus 10. So step 2 says, plug in that new value for x into the other equation, way up there. So 3 times the quantity 2y minus 10 plus 5 times y is equal to 25. We've got one equation with one variable, so I can solve it for y. Step 3, I solve it for y. So I distribute my 3, and I get 6y minus 30 plus 5y equals 25. I'm going to combine my y's. I get 11y minus 30 equals 25. And we're going to solve for y. So I add 30. I get 11y equals 55, which gives me y equal to 5. So we've gotten our value of one variable. We're going to take that y value and we're going to plug it back into the equation from part 1. So I get x equals 2 times y, so 2 times 5, minus 10. So that's 10 minus 10, which just gives me 0. So x is 0, y is 5, so my solution is 0, comma 5. Again, one solution is one point. It's a point of intersection. So if I instead wanted to solve these graphically, I could graph the two lines, and the point where they intersect should be 0, 5, which happens to be a y-intercept. All right, our next example is going to have no solution, so let's take a look and see what that looks like. Following the same steps, step 1, we're going to solve equation 1 for x, because that's the easiest thing to do. So I'm going to add 3y to both sides, and I get x equals 3y plus 7. Now we want to plug that in. In step 2, we're going to plug that in for x in equation 2. So 2 times the quantity 3y plus 7 minus 6y equals 15. Step 3, solve that new equation for y. So I distribute my 2, I get 6y plus 14 minus 6y equals 15. So you can see 6y and a minus 6y, those are going to cancel out, and I get 14 equals 15. So if you remember from chapter 1, when we're solving equations and we get a false statement, okay, that means that we have no solution. So there's no xy point in common to both of these lines. Again, that means graphically that there's no point where these lines cross, making them parallel lines. So our last example for the day is an example where we have infinitely many solutions. Following the same steps, I think it's easiest if we solve equation 2 for y by dividing by negative 1. So I'm going to get y equals negative 4x plus 2. I'm just switching the signs in all those terms in equation 2. Step 2, I'm going to plug that value for y into my first equation. So I'm going to get 4x plus y, which happens to be negative 4x plus 2, and that's equal to 2. So my positive 4x plus my negative 4x, those are going to cancel out. So when I'm solving my equation, I get 2 equals 2. This is true, which means that we have infinitely many solutions. Graphically, that means the lines cross at every single point, which means they're the exact same line. So there's one example for you to try here, solving using substitution. Once you get your answer, x, y, right, as a coordinate, x comma y, and go ahead and, for this example, practice by plugging it back into both equations to make sure that the work checks out and that you got the right answer.